Welcome to the Study Prep Guys Chill Zone, everyone. We'll be covering off elements and compounds for chemistry for CSEC. This is a summation of our the Study Prep Guys audiobook on CSEC chemistry. Today you will be learning, or the learning outcomes is right formula to represent ions and molecules. Secondly, our main objective is write balance equation including state symbols to represent chemical reactions referred to in the syllabus. We're looking at C6 syllabus. This is chapter 4 on elements and compounds. So first of all, what is an element exactly? An element is a substance which cannot be broken down into any simpler substances by chemical means. So an element is when, for example, when muric oxide is heated, it decomposes into oxygen and mercury. However, both oxygen and mercury cannot be broken down into anything simpler. There is nothing to break down oxygen because oxygen is an element, and an element cannot be broken down any further. So oxygen and mercury are examples of elements. There are other examples of elements, but for now we're looking at oxygen and mercury. Oxygen, we breathe in oxygen. We cannot break down oxygen into any simpler elements because oxygen is an element. Moving on, let's look at elements in continuation of that. So elements are the fundamental building blocks of matter in our universe. Without elements, we won't have the basic things or the basic things to actually support life in general or create life. There are about 92 natural elements and more than 10 man-made elements. These man-made elements were created probably in a lab, and each element has a name and a chemical symbol. And that's where we have the periodic table. Um, and each element has a name and a chemical symbol. So it not only has a name, but it has a chemical symbol that represents that element. So a list of elements with their symbols is given in the periodic table, and you would usually find this in your class. You would usually do this in your chemistry. They would go over basic chemical compounds such as beryllium, zinc. These are some examples of that. So let's look at atoms of elements. So, if we look at an atom, any element is made up of only one kind of atom. So, for example, gold is made up of only gold atoms, and that's the same thing with, like, for example, with diamond. However, like for example, with oxygen, it's made up of molecules each consisting of two oxygen atoms, while ozone is made up of three molecules each containing three oxygen atoms. If you take a look at the diagram, we see that gold atoms, it is composed of oxygen and ozone. So moving on, our next course of detail is metals and nonmetals. Elements can be classified into metals and nonmetals, and there's a certain part of this in the periodic table. But let's wait for that. I will go over the periodic table in a later video, so stay in tune with that. So metals are usually hard and shiny. They are malleable and ductile, meaning that first of all, metals such as metals such as stainless steel are very hard to break. They're very condensed, and the molecular buildup of it is um very hard to break. You can't really break metal. So it's ductile in the sense that, for example, with copper as a metal, that is very easy to break. It's very easy. And not only is it easy to break and ductile, depending on the type of metal utilized, all metals have a similarity in the conductivity of heat and electricity. So to be a metal, you need to be malleable, you need to be ductile, and you need to be a good conductor of heat and electricity. If you do not fulfill these three basic requirements, you cannot be considered, or that element cannot be considered metal, because 99.9% of metals are electrically conductive. And thirdly, non-metals are usually soft and brittle and are poor conductors of heat and electricity. Moreover, there are more metals than non-metals. So sulfur is a non-metal, and copper, for example, is a metal. So you could draw the silver lining between the two. Moving on. So this is a quick check or a quick question you could answer. Magnesium is an element. Explain what this statement means. Explain what is an element. Explain what makes it an element. And And secondly, a piece of copper can be broken down into very tiny pieces. Hence, copper is not an element. Explain what is wrong with this statement. Thirdly, give the symbol for each of the following elements. State whether it is a metal or non-metal: mercury, lead, silver, chlorine, strontium, and tungsten. And I'll just pause. You could pause the video for a couple of minutes, and then you could come back to the solution. So I'll give you a couple of seconds. One, two, three, go. All right, let's start back with the video now. So the solutions. So first of all, if you got the answers correct, you could type in the comment below. So first of all, magnesium is an element because it cannot be broken down into any simpler substances. Magnesium is made up of magnesium atoms and nothing else. So magnesium is an element and it fulfills that requirement of what element is. Secondly, a piece of copper cannot be broken down into very tiny pieces, but each tiny piece of copper is still made up of only copper atoms. Hence, copper is an element since it's only made up of copper elements. And thirdly, mercury, um, mercury, metal, lead, silver, and as you could see, AG, and you could see the symbols for these different elements. And if you have gotten it correct, type in the comments below. So now let's move on to what is a compound now. So a compound is a substance made up of two or more elements chemically combined together. So when you have two or more elements combined, that's what we call a compound. Mercury oxide, which is a combination of mercury plus the oxide, is not an element because it is not made up of it's not made up of only oxygen and it's not made up of only mercury. It is made up of mercury and oxygen. So it is called, or thus it is thus called, a compound. So to be a compound, you need to be made up of more than one elements to see. So let's look at atoms of compounds. So a compound is made up of molecules. And what you may ask yourself the question, what is a molecule? A molecule of a compound is made up of two or more different types of atoms chemically joined together. What does that mean? So unlike a compound, which is made up of elements, a molecule of a compound is made up of two or more different types of atoms. Listen to that term, atoms. A molecule is made up of different types of atoms. An element or a compound, let's say, sorry for that, a compound is made up of different types of elements, while a molecule is made up of different types of atoms. So atoms, or sorry for that, um, so a molecule is made up of different types of atoms, while a compound is made up of different types of elements. So there's a differentiation between that. So, for example, we have water molecules, we have carbon dioxide molecules, and carbon dioxide is usually emitted. We have other means of molecules, such as chlorofluorocarbons, which is a spray that we use to make the environment smell clean and stuff like that. We have carbon dioxide, which is usually emitted from factories, which is a mixture of different atoms chemically combined and it creates a black smoke. We have methane molecules is another example of what a molecule is. Moving on, let's look at the formulae of compounds. So, as a compound has a fixed composition. So, for example, if we have H2O, and H2O is usually emitted or usually has, or it usually always has, two hydrogen atoms and one oxygen atom. So the formula of compound shows the symbols of the elements present. It shows what elements are in it. And not only does it does that alone, it shows a ratio of atoms present also. For example, water has a formula H2O, which could be represented by H2, and that H2, that small abbreviated 2, we that has two, it represents with the H, the small 2, it represents two hydrogen atoms, and the O by itself, which is the symbol for oxygen, illustrating that it has two hydrogen atoms and one oxygen atom. Moving on, let's look at the formulae of some compounds. We have carbon dioxide, which is CO2, illustrating that it has one carbon atom with two oxygen atoms. And we have methane, another element, another compound, sorry for that, CH4, which shows that it has one carbon atom with four hydrogen atoms. We have sulfuric acid, which shows two hydrogen atoms with one sulfur atom and four oxygen atoms. We have magnesium hydroxide, which is Mg with the abbreviated or in bracket OH with the small 2, I like to call it. I just use small 2 to make it more simpler. Um, you small. I like to call that small 2. We call that a syntax, but we'll look at those terms in a later video. So one magnesium, or we call it small 2, a symbol, but personally, I like to call it a syntax. So one magnesium atom with two oxygen atoms and two hydrogen atoms. So when we use that term abbreviated in it, when we use that OH and we use that small 2 outside of it, outside the bracket, it shows that both of these oxygen and hydrogen as two atoms in place. So moving on, we have the valency of an element. Sorry for that bad pronunciation error. To help us write chemicals formulae more easily, we can use the valency of an element. The valency of an element can be treated as the combining power of an element. The valency of an element is related to the electrical structure of the atom and the group number of the element in the periodic table. A good example of this is the valencies of some common elements or metals. For example, we have hydrogen, the valency is 1, which is the cation. So we have anion, which is positively charged, and cation, which is negatively charged. Well, sorry for that, is anion negatively charged, cation positively charged. That my error. Sorry for that, guys. But let's go on with the topic at hand with valency. So hydrogen valency is 1, symbol H plus, which is a positively charged. Sodium 1, potassium 1, copper 1, calcium 2, um, magnesium 2, zinc 2, copper or copper 2, iron 2, and we have aluminum, which is 3, and iron, which is 3. So let's look at the valency of some non-common elements or not metals. And we have, as I said before, if you could look back into the symbol, which is cation, remember this is very important. Cation are positively charged, anion are negatively charged. Now let's look at some of the non-metals, their valency and their symbol and anion or their anion charges. So chlorine, which is 1, has a valency of 1, and the symbol is Ci with a negative charge. Bromine 1, bromine with a negative charge or negative 1. Iodine with a negative charge of 1, and we usually just put a negative symbol because we don't want to put in the 1. And that's just chemistry, guys. Oxygen 2, oxygen has a negative charge of negative 2, and we put in that negative 2. Sulfur likewise has a valency of 2, S to the negative power of 2, or the encryption. Nitrogen with a valency of 3, negative 3. Moving on, let's look at the valency of some group atoms. And this is ammonium with a valency of 1. The symbol is NH4 plus. Hydrogen with 1. Valency is OH to the negative. Nitrate 1. NO, the 3 to the negative 1. Hydrogen carbonate. Sulfate 2. And these symbols, I will go in detail with the symbolism, but for now, this is our review class for CSEC students writing CSEC chemistry on for this year. Carbonate, we have 2, 3 to the negative power of 2. So elements and compounds will be continuing. Metals or cations can react with non-metals or anions. So I'll just get that out. So something that you really do need to understand is that metals or cations, which are positively charged, can react with non-metals or negatively charged metals or anions to say. When a formula is formed, the positive charges of the cation have to be balanced by the negative charges of the anion. The total charge of a neutral compound must be zero. Example, sodium chloride Na plus Ci negative equals NaCl. So both the negative and positive charges have cancelled out each other in that case. If you could look at chemical compound Na plus the Ci negative equals the NaCl. And if you're doing maths, we know that two negative charge create a positive, and when a positive and negative charge comes into play, it creates a neutralization point. So you don't see it, but it's there. We have the copper I oxide, which is the Cu 2 plus the um, O2 negative creates a new element in itself, which is MgO. So another example of this is magnesium chloride. So if you could look at that, we have Mg2 plus the Ci negative times the 2. And the two elements, if you look at it exactly, Mg plus the Ci negative times the 2, both of the elements cancel out each other. But we still have two elements remaining. We still have two elements remaining because, as I said before, if you look at the bracket, it means everything in there is times, or it has two atom elements in it. So it cancel out each other, but we still have that two remaining, and we put that on the outside, represented still has two elements remaining in it. We have aluminum oxide, and we have ammonium sulfate, and so likewise. So just a quick check. You could write the formula for each of the following compounds. As you could stick the video and pause it right here, and write in your formula for the following elements. All right, guys. If you finish, let's check the answers now, and then you could tell me in the comments below if you got it right. So that is the formula for, or the formulae, I like to call it, for the solutions of the quick check tree, or the questions under that branch. So if you have gotten all right, tell me in the comments below. I really do appreciate the support, guys. Moving on, let's look at writing chemical equations. So writing chemical equations is not difficult. So usually when we hear writing chemical equations, we say it's difficult, it is hard, it is not hard, it is not difficult. So word equation, we have mercury plus oxygen, which is the reactants, and then we have mercury oxide, which is the creation of a new product. So a chemical equation tells us what chemical changes take place during a reaction. It tells us what the reactants, which are the things that react, in this case mercury plus oxygen, and what the products, things that are formed, are. A chemical equation must be balanced. What does balanced mean? This means that the total number and types of atoms on the right side of the equation must be equal to those on the left side of the equation. This is because atoms cannot be created or destroyed. Atoms are permanent, they do not change, they are there all the time. So let's look at writing chemical equations. We'll do a step-by-step process. So we have mercury plus oxygen, the same example, equal mercury oxide, but how do we get to that point? So step one, write down the chemical formula for each reactant and product. For example, we have Ag plus the O2 equals MgO. So first of all, the first thing that you need to do is count the number of atoms on each side of the equation. So on the left side, we have one Hg atom plus two O atoms. So on the right side, we have one Hg atom plus one O atom. So, or one oxygen atom, or two oxygen atoms in this case. How do we balance that? So on the left side, we have one Hg atom, and we have two oxygen atoms on the left side. How do we balance that off? Let's go into the third step now. So you need to make it even. So to make it even, we put um Ag plus the O2, we have 2HgO on the left side. So the balance equation add 2 in front of the AgO and again count the number of atoms on both sides of the equation. So if you look at it, the equation is still not balanced because the left side has one less mercury atom. Right guys? Hopefully you're following along. So the equation is not yet balanced. If you look at both sides of the equation, the equation is not balanced because on the right side, if you look at it on the right side, it still has one less oxygen atom. And on the left side, one less mercury atom. So it's still not balanced. And that now takes us to the fourth step. The balance equation add 2 in front of the Hg. And again, count the number of atoms on both sides of the equation. So if you look at it now, on the left side, we have two Ag atoms plus two O2 two oxygen atoms, and we have two Ag atoms plus two oxygen atoms. So now it is balanced. It is balanced now from the initial equation. So the equation is now correctly balanced. Since we have two hydrogen Hg at or we actually now have a balanced equation, because not only do we have two oxygen atoms on both sides, but we also have two Hg atoms, I like to call it, on both sides. So now the equation is correctly balanced. You could count the number of elements on both sides and you will see that it is correct. And when we utilize this 2 here, you could look right down at the bottom below. This 2 represents the two Hg atoms and the two oxygen atoms also. So everything here has 2. So 2 Hg plus the two oxygen atoms. So that fulfills the balance equation. So this equation is now correctly balanced. So first of all, let's look at one of the most important fundamental concept, which is state symbols in chemical equations. So the state symbols tells us the physical states of the reactants and products in a chemical reaction. For example, we have S, which is the solid state, I, or the L, which is the liquid state. Sorry for that, it's not I, it's L. We have G, which is the gaseous state, and we have AQ, which is very popular, I like to say, the aqueous state or solutions in water. So write a balanced chemical equation with state symbols for the reaction between dilute hydrochloric acid and limestone chips calcium carbonate. So if you look at this equation is not yet balanced. It is balanced, but I like to keep that for now. So this is an example. I will not work it out. It's just an example, so you guys could ponder about it a little bit. And now this is the fun part for you. I'll stick the video. Balance the following chemical equations by writing numbers in the blank spaces provided. The number can be differentiated for you, but work with instinct. You guys have done this before. Just continue doing the great work. So you could pause the video for a quick couple of minutes. You could work it out, and I'll just count to 1, 2, 3 if you have finished it. Now let's move on to the solutions. So this is the solutions for it. You just had to actually write in the solutions, the products of the reactants. And if you have gotten all of it correct, tell me in the comments below. So this is it. So first of all, it was actually a bilateral or unicameral, like they call it, a unicameral question. So first of all, you have to write the word equation, and then after that, you have to write in the state symbols. And if you have gotten all of that right, if you have done all of it, and I could bet that majority of you guys haven't actually done all of that. But if you have attempted, still tell me in the comments below. I still appreciate your thoughts on this, guys. So let's move on. So that's everything for this video, guys. If you like video like this, or you want to be educated on CSEC chemistry, subscribe to Subscribe Guys Chill Zone for more references, or if you haven't understand concept thoroughly or enough yet, you could check out Chemistry for CSEC Examinations by Mike Taylor and Tania Chung, Or you could check out Longmont Chemistry for CSEC by James Clark and Ray Oliver. If you enjoy videos like this, subscribe, hit the notification bell, and see you guys on the next video.